Hi, welcome back to Learn, Do and Grow. I'm Sok. Today I'm going to share with you one question on the topic of ratio. It is quite difficult to see it without drawing the model. So I'm going to show you how I use model to help you understand or rather visualize the question better. And then after that, I also share with you a technique. I'm going to share with you a technique that you can use to solve other ratio questions. Okay, this is the question. Sam had some marbles in a red box and a blue box. He decided to take 1/3 of the marbles from the red box to put it into the blue box. After the transfer, the ratio of the number of the marbles in the red box to the number of the marbles in the blue box is 5 to 7. What is the original ratio of the number of marbles in the red box to the number of the marbles in the blue box? It would be good if you can pause this video for a while and try to solve this question first. So when you see the solution later, you will learn better. I'm going to go through the solution with you, and after that I will explain on why am I doing certain way and how do I get to that step. So let's start. Let us look at this sentence. 1/3 of the marble from red box to blue box. So this is how it means in model. Red box, and after that 1/3 is taken out. That's why it is a dotted line. So we left with 2 unit over here. After the transfer, blah 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 blah, red box to blue box is 5 to 7. So we draw something like that. Red box 5, blue box 7. So if you notice, this one part over here or 1 unit over here is not equal to 1 unit over here. So in this case, I consider it as case 1 and this is case 2. Okay, if we just look at this alone, it is not going to help us to solve the problem because we are looking at the original ratio. And in order to know the original ratio, you need to know over here, the red box, the number of marbles or the ratio itself to the original of the number of marbles in the blue box. But in this case, we can't do the comparison because the unit itself is not the same. The quantity in the red box over here is not the same as the quantity in the blue box over here, 1 unit over here. So it's not the same. So the only thing we can do right now is that we need to standardize the unit. I'm going to show you how I am going to do that. So look at here. This is the number of marbles altogether, okay, after the transfer that belong to blue box. So I just put it as it is. But remember, 1/3 of the marbles in the red box was transferred over here. So in this case, this one bar model need to be split into 2, which is the one transfer from the red box and the one that is original. So at least something is clearer right now. Again, we still cannot compare and we need to find the standardized units between case 1 and case 2. How are we going to do that? So normally, I'm teaching my student to do this. We need to look for the lowest common multiple of 2 and 5, which is 10. Why do I do that? If you notice, I purposely draw this model to have the same length. Look, the model that belong to the red box, and this one, the before and after, they have the same length. Why? Because the quantity of the marbles doesn't change, and this is very, very important. The moment we draw this one not equal, it is very hard to solve this question. So you need to understand that when a quantity of the marbles in the red box for the before scenario and the after scenario is the same, the length of the models should be the same. So in this case, we have 2, 1, 2. I call it 2 part. And over here, we have 1, 2, 3, 4, 5. We have 5 units. So how am I going to do that to make sure that they have standardized unit? Since the quantity is the same, I can make the number of units for case 1 over here, which is the before model, and the number of unit in the case 2 over here to be the same. So over here is 2, over here is 5. What is the lowest common multiple of 2 and 5? Which is 10. Over here is 10 unit, and over here is 10 unit 2. So if this is 10 unit for 2 part over here, then 1 would be 5 unit. And similarly, over here 10 unit, then 1 would be 2 unit, right? Then we can link back to the blue box. Over here should be 14 units. 2, 4, 6, 8, 10, 12, 14. Then you see a complicated question can be simplified to just a basic one. From now, you can see that if I know this is 14, this is 5, okay? Then what is this? It's just a basic comparison, right? Comparison model. I have this one, long one, and have a short one. Consider it as one part. Consider it as another part. But one whole is 14. So now the complicated model becomes just a basic comparison. From here, 14, 5 minus 5, then equal to 9. Now you notice, over here, it is just the original number of units that belong to the blue box. And what about the red box, the original one? It can be found here too, right? Now 5, 5, 5. So altogether is 15. So the original ratio of the numbers of marbles in the red box to the blue box is 15 to 9, and we can simplify it into 5 to 3. Now you can see that a ratio topic can be so complicated that it is very hard to visualize it. But if you master the model drawing, it is very easy to visualize the problems and can find the hidden information. This is called hidden information. And especially if you are the parents and you want to help your children, I would suggest that you should draw model first before starting on explaining the ratio to your children. It is very difficult to visualize the ratio topic on itself. So once your children understand this type of model and he understand or she understand why do I need to do the LCM, the reason behind it, then it is very easy when they move on to ratio topic. So in the next slide, I'm going to share with you on a different way of solving this, but kind of quite similar. Okay, so the question is the same. Let me go through quickly. Red box is the same. The only part that is different is I write it in ratio, and majority of the student, they tend to do that. So when they write ratio, after that they get stuck and get lost because they are unable to visualize the hidden information. So I'm going to tell you how to do that. So over here, 5 to 7, so over here is 5 units to 7 units. Okay, next, remember this 5 units is after the transfer, but what about this 2 part? Where does it come from? This 2 part is come from over here. And why do I put it on the same place here? Because they have the same quantity. After the transfer, although I have 5 units, meaning I split it into 5 parts, but the quantity stay the same. And the quantity equal to this leftover one, the same quantity. Again, they have 5, they have 2, it is very hard to compare, so I had to find the lowest common multiple of these two. Then in that case, the lowest common multiple of 5 and 2 is 10. In that case, what I'm saying is I subdivide into 10 subunits. And from 5 to 10, how many times increase? Increase by 2 times. So in that case, my ratio over here also increased by 2 times. 7 times 2 equal to 14. Now, you know, these 2 parts equal to 10 units. In that case, 1 part equal to 5 units, subunit over there, right? And 5. And the ratio, again, the same as the previous slide. You can see that over here, 15, which is the original one, and 9, where does it come from? Over here, the after, they have 14 subunits, but remember, within the 14 itself, I have 5, right? 5 units, so I minus 5 equal to 9, and it is 5 to 3. So you look, ratio itself, it can be quite fast if you understand it. But if you don't really understand the ratio topic that well, or the concept that well, I would suggest that you should start with model first. With model, it is easier for you to visualize the problem itself, and it is easier to see the hidden information. By the way, I'm writing a book to help all the students to solve problem sum using model, and that involve a very simple step, and the techniques can be used for all the topics involve whole number, fraction, percentage, ratio, decimal, and one method that can solve majority of the questions. If you want that ebook, you can leave a comment below so that I know that once it is ready, I can send it to you. So thank you for watching.